Applications rely a lot on the value of conditions to determine what to do. For example, an ATM compares the amount of money in the account to the amount that you're trying to withdraw, and it will only dispense the cash if there is enough in the account. The player in a game can continue playing if there are enough health points, but the game ends if the player doesn't have any health points left. A website that requires a username and password will only grant you access to the restricted area if you provide the correct combination of username and password. There are countless other examples of situations in which a condition must be true or false for an application to perform certain actions. Conditional statements allow us to specify code that runs if a condition is true, and optionally allows us to specify other code to run if that condition is false. JavaScript has an if statement, which looks like this. This consists of several parts. The first is the keyword if, which is followed by a condition surrounded by parentheses. The condition is then followed by code that will only run if the condition is true. If you only have one line of code to execute, you can omit the braces. Changing the condition to false prevents the console log from running. If you have more than one line of code that you want to run when the condition is true, you must surround all of that code with braces. This creates something known as a block. There's no limit to how many lines of code you can put inside of a block. The whole block's code will execute if the condition is true. If you accidentally omit the braces when trying to make a block, only the first line of code will run conditionally, and the rest will run unconditionally. Notice that the second console log still runs if I change the condition to false, but the first console log does not run. The indentation has no effect on whether or not the code runs. I deliberately left it there to emulate a common mistake. If you're quickly glancing at this code and that second line is indented, you might fail to notice the missing braces and incorrectly assume that this second line will only run if the condition is true. Note that the values of true and false that I used do not have quotation marks. These are not strings. They are values of a type known as boolean. Boolean values can only be either true or false. Also note that the literal value of true or false is not normally used as the condition for an if statement, which is why my editor has marked it with a warning. The main exception is a temporary true value used in testing to ensure that the code inside the block is correct. Placing a true value as the condition guarantees that the code in the block will run, so you can test if the code inside the block actually does what it should, even if the real condition that you want to use will actually be false. Under normal circumstances, the condition provided is a variable that has a true or false value, or it's an expression that can be evaluated to a true or false value. There are some other possible conditions besides these that we will discuss in a future video. Here's an example in which the condition is an expression. We haven't covered comparison operators yet. The less than sign works in a similar way to how it works in mathematics. If I just do a console log of the expression, we can see that it outputs the Boolean value of true. The value of whatever is in between the parentheses is evaluated first, and the expression 3 less than 4 is true, so it would be the same as if I had written true as the condition. Since comparison operators are used extensively with if statements, we must take a moment to discuss them in more detail. The greater than operator also works as you would expect. 3 is not greater than 4, so this outputs false. The symbol for greater than or equal to is not easy to type on the keyboard, so we use the greater than sign immediately followed by the equal sign. Both of these output true because 4 is greater than 3 and 4 is equal to 4. Note that there should not be a space between the greater than and the equal sign. Separating them causes an error. The order also is important. The equal sign cannot come first. This combination has a totally different meaning, which we will discuss in a future video. The less than or equal to works in a similar way. We put the equal sign immediately after the less than symbol. These both output true because 3 is less than 4 and 3 is equal to 3. There are two different equality comparison operators in JavaScript. Using 2 consecutive equal signs is called the equality operator, and using 3 consecutive equal signs is called the strict equality operator. Before I explain the difference, let's look at both of them in code. They both output true because 3 is equal to 3. If I change one of these values being compared to be a string, we get different answers. Using the double equal sign results in true, but using the triple equals results in false. The double equal sign tests for something known as loose equality. It allows the types to be different. We haven't explicitly covered the topic of types yet, but we have seen examples of several different types. Numbers, strings, and booleans are all different types. The number 3 without quotation marks is a number type, and the 3 with quotation marks is a string type. Since they are different types, a strict equality comparison between them will always be false. The loose equality comparison allows the expression to be true despite the difference in types, but the values still have to be equal when ignoring the types, so a loose equality comparison between the number 3 and the string 2 would still be false. The final comparison operators that we will cover are for inequality. As with the equality operators, there are 2 versions. The first one is an exclamation point immediately followed by the equal sign, which checks for loose inequality. The second one is an exclamation point followed immediately by 2 equal signs, which checks for strict inequality. Both of these output true because 3 is not equal to 4. If I change the 4s to 3s, both statements output false because 3 is equal to 3. However, changing some of the 3s to strings results in different outputs. The number 3 is loosely equal to the string 3, so a loose inequality comparison between them results in a false value. The number 3 is not strictly equal to the string 3 since they are different types, so a strict inequality comparison between them results in a true value. Note that all comparison operators are capable of using literal values, variables, or a mixture. I have been doing console logs of the results of using comparison operators, but they can be used directly inside the condition part of an if statement. It is also possible to save the value of a comparison in a variable and use that as the condition. Because first number is less than second number, the value of result is true, and a true condition causes the code to execute. An optional else clause can be added for code that you want to execute when the condition is not true. This runs the code in the else block because 3 is not greater than 4. It is also possible to check an alternative condition when the initial one is false. This is done using an else if clause. In this example, isMember is true, so the code block associated with it runs. If we change the values to make isMember false, but the age is over 65, the code for the else if block runs instead. Let's look at what happens when both conditions are true. Because the isMember variable is true, the code associated with it runs, and the code in the else if block does not run despite its condition also being true. These code blocks are mutually exclusive. The code associated with the first true condition encountered is the only one that runs. Because of this, it is important to specify the order correctly. Let's look at what happens when we reverse the order. Because the age is over 65, the first code block runs and the second one is ignored. If this was a real retail application, the customer would get the smaller 5% discount when they are actually entitled to the larger 10% members discount. It is possible to have more than one else if clause, and when there are many of them, problems caused by incorrect ordering of conditions becomes more likely. This code represents a common letter grading system, but omits the plus and minus variants for simplicity. The score of 88 gets a grade of B because it is not greater than 90, but it is greater than 80. If we rearrange the order of these conditions, we will get an incorrect result. The same score of 88 now gets a D, because 88 is not greater than 90, but it is greater than 65. 88 is greater than both 80 and 70, but those other conditions are ignored, because a true condition has already been found, so be careful with the order of conditions, especially when there are many of them. There is still plenty more to say about the topic of the if statement, which is why this video is marked as part 1. We will continue with this topic in the next video.